Number 40, your family spends $60 on tickets to a hockey game, $4 per hour for parking. Total cost, C in dollars, is given by the equation C equals 60 for the tickets, plus 4T, where T is the time in hours your family's car is parked. So it's $60 for the tickets plus $4 an hour for parking. Graph the equation. Since we can't have negative hours or negative dollars, I'm just going to focus on the first quadrant. A real world problem, I always want to label my axes. So I'm going to call, let's see, they say C equals 60 plus 5.5T. I like to think of it as Y equals 60 plus 5.5X. Okay, so my X variable, what is that? That's my time, how long I'm parked in hours. My Y variable is going to be our cost in dollars. Okay, in this equation, we can recognize, since it's in slope-intercept form, you've got the Y by itself. The slope, the coefficient of X, is 5.5, and the Y-intercept, the number by itself, is 60. So here's my beginning point. My Y-intercept is 60. My slope is 5.5. Since I jump all the way to 60 as my initial price, just for the tickets, I'm going to heartbeat this, and I'm going to go up to 60. And since our slope is 5.5, I think I'm just going to be convenient here and pick 5s for my scale. 65, there'd be 70, 75, 80, 85, 90, and so forth. So if I don't park, if I park for 0 hours, my Y-intercept, my beginning price is $60. That's just for the tickets. Now, our slope is 5.5. Think of it as 5.5 over 1. So basically, the price goes up $5.50 for 1 hour of parking. It would go up $5.50 more for another hour of parking. It would go up $5.50 more for another hour of parking. So if we connect this, we want to make a ray, so it's not going to go into the negatives. And theoretically, we could park for a really, really long time, so it would go up, up, and away. There's part A. Part B, suppose the parking fee is raised to $5.50 per hour so that the total cost of the tickets and parking for, oh nuts, $5.50, I was looking at the wrong equation. Okay, well we just graphed B, so it's not too bad. Let's graph A. It's $60 plus $4 an hour. So if we had Y equals 60 plus 4T, I'll do this one in red. Here, my Y-intercept, the beginning value is still 60, but now the price only goes up $4 an hour. So that's our slope, 4. Think of it as 4 over 1. Rise $4, run an hour. Rise $4, that would be to 68, run an hour. Rise $4 to 72, run 1. If I graph that one, shoot, I wanted a different color. There we go. If we graph that one, we can see the difference between the two. So A is done, we graphed it. B is done, we graphed it. C, how much more does it cost to go to a game for 4 hours after the parking fee is raised? Well, if we go to 1, 2, 3, 4 hours, we can see it's going to be about $75 versus the total cost looks like it's about maybe $83. So a difference of 75 to 83, a difference of about $8. Now, we could always double check our work. How much did the price go up? It went from $4 an hour to $5.50. So it went up $1.50 an hour. Well, if I stay for 4 hours, if we times it by 4, $1.50 times 4 is actually going to go up $6. So being that a graph, sometimes it's hard to estimate. You might not get the exact value. Algebraically, we get $6. Graphically, if we estimate $8, they're pretty close.